welcome to the latest Hitchhiker's Guide to Precision Viticulture. Thank you for your patience. We're having a pretty wild lightning storm outside, so we're having internet problems and trying to figure that out. So if we lose you, stay with us. We'll try to get back on as soon as we can. Okay, so today we're going to talk about shoot thinning, mechanical shoot thinning as a component of the complete system for mechanized viticulture pioneered by Justin Morris and Thomas Olridge. And this shoot thinning is going to be a little different than what you're probably used to. Here we're using precision viticulture technology, and the way we're kind of stepping up and following from Justin Morris's lead is by using variable rate technology so that we're not only mechanized shoot thinning, we're doing so variable rate. So to break tradition, I'm going to let Kevin go first today, and he's going to lead off talking a little bit about economics. I have some cost-related information included in my presentation from our experimental trials too, but we'll try not to double dip for you. So without further ado, I'll turn it over to Kevin and then touch back in with you for the rest of the webinar.
Thank you, Jackie. So one of the things I want to discuss today is mechanical shoot thinning in general, in part because this looks like an important practice for the adoption of sensor technology and mechanical management of variable rate zones. But that being said, one of the disadvantages is here in the East, at least, mechanical shoot thinning has not been commercially adopted by the industry. In our history, most of our vines were hand pruned, at least going back to the 80s, and we still have not fully adopted mechanical pruning. So this system probably integrates a little bit better into a mechanical practice, and as we get there, I would expect that we would slowly adopt things like mechanical shoot thinning, and we'll talk a little bit about why that is, and then put it in terms of the variable rate sensor technology and what shoot thinning offers that maybe some other practices do not. So even though it's not commercially adopted just yet, we do have a couple shoot thinners in the area. So that being said, we do need to entertain the cost of actually mechanically shoot thinning. The total capital investment would be anywhere from $5,000 to $60,000. The commercial availability of these machines is now somewhat limited. They were offered by Oxbow, and there's been a transition in that market. For $60,000, you're looking at something that we don't have an image of here, but essentially looks like two shoot thinners doing 2 rows at once from a trailer. In that $5,000 range, it would probably be something that was somewhat built by a grower. A lot of the hydraulics and tool arm type portions of the equipment can be shared with a pre-pruner, and a do-it-yourself option, I think, would certainly be one of the options available to a grower. And that's when it was commercially available, and if it becomes again, if you already have the tool arm and everything like that, the cost of the actual shoot thinner was very affordable in that $5,000 range. We want to target a total cost of $40 per acre for shoot thinning itself. That would include the capital costs, the depreciation on the tractor, and the operating costs that are associated with covering the acreage. The ability to meet or beat that target is going to be contingent on what an individual grower's situation is. Mostly, and Jackie may touch on this, because the window of time to actually do shoot thinning is very narrow. So with multiple varieties and multiple microclimates, you could see a shoot thinner that would be able to hit maybe 2 to 250 acres of grapes. But with a single variety on a single in a single area, in a single block, it would be much harder to get above 50 or 60 acres. So there's going to be some variance based on individual farms in terms of how much ground they're going to be able to cover, which will obviously impact the cost of shoot thinning. We certainly do have a couple growers that if this became a widely accepted practice, would actually need 2 mechanical shoot thinners. And in California, obviously, that would be the case with some of the really large acreage they have out there as well. So in general, though, with those targets, if you even approach them, this is a cheaper option than fruit thinning, and we'll get into some of those numbers. It is possibly more effective on smaller vines than fruit thinning is, although it probably works best in conjunction with fruit thinning. So in addition to, not just as a separate option. and it certainly increases quality control in a mechanized system. So we could take this machine and upgrade it to something that we can use in a variable rate way relatively inexpensively. It's probably not going to be the first thing you upgrade. So the tractor computer should already exist on the operation. The GPS should already exist as well. You may have $7,000 to $10,000 invested in those systems, and maybe a little bit more. But you're looking at about $2,000 to upgrade this equipment. Could be a little more, a little less, depending on what cabling you use and what actual tractor computer you're using. But like I said, it's a relatively affordable option to add onto a system, a farm that's already smart. Like I mentioned earlier, this is going to be a 1 to 2, maybe 3 week in the most extreme situation time period. So most growers will not need a dedicated tractor computer or GPS for this activity. And an enterprise budget that would share that capital costs of technology across the whole farm would probably add about $5 per acre to the cost of chute thinning. So it would go from our target of $40 to $45 per acre. So we also need some data, some actionable data, and this is going to be a little trickier than some of the other data we've used. It may in fact be the same data. It may be gathered from NDVI or imaging technology, but everything needs to happen faster. So certainly this is not something that's commercially available yet. I would expect just the cost of the sensors to double. I think most people who are fully using one sensor would need two because you're covering more acreage more quickly. And you may actually need to dedicate resources to gather that data. So typically speaking, we talk about how gathering data is essentially free because we mount it on a sprayer or a vineyard mower or a disc, and we gather this data while we're doing something else. And we can't. I don't think we can guarantee that that data is going to be timely enough for chute thinning. So there may be situations where you do need to gather data. But if you're using an ATV or a side-by-side and you're doing multiple rows in a single pass, the cost of that's going to be very low. So you're probably looking at an additional $10 per acre to actually get the data, and it should be at least $10 per acre for processing through a consultant. If this is some technology that we can develop so most of the processing is done by farm expertise and maybe with the help of an extension agent, it may possibly be free, but we're certainly not there yet. So a little more detail on what it costs to adjust crop size and what the alternatives are. And so this sort of illustrates the economic benefits of variable rate chute thinning. So what do we do if we don't variable rate chute thin? We can decrease potential crop through pruning. So basically what we're trying to do when we chute thin is to get the crop size correct. And one of the ways that was done historically was just to make sure that you never had too much. You can do that through dormant cane pruning. And probably what approximately you need to do is remove 3 tons more than you would in our climate otherwise to make sure that you don't have too much. In the last 5 years, that would have resulted in a lost potential crop or a lost actual crop of $1,640 per acre. The lost potential crop would theoretically be valued at more than that, but we've had at least 1, maybe 2 instances, depending on specifically where you're located in the belt, where you would have had to actually thin off some of that potential crop. So that's one option. It's not a great option because you've left almost $2,000 per acre on the table in the last 5 years. The other option is to fruit thin, which is not exactly an industry standard, but it's what most of our growers do in the East. You're looking at about $120 per acre per pass in periods of low prices and some of the climate we've had in the last 5 or 6 years with very high fruitfulness. We've seen multiple passes necessary. This is where certainly fruit thinning in conjunction with chute thinning makes a lot of sense because you're saving about $80 per pass, maybe $75 if you're doing it in a variable rate way. The other thing that growers need to do is have the ability to decrease crop load to increase vine size. So not necessarily to just make sure the crop is balanced, but to rehab a problematic vineyard. Your alternative practices are high-intensity hand follow-up or high-intensity hand pruning, which adds an additional $110 per acre from regular hand follow-up. And that's obviously problematic, and the fact that we can replace this mechanically shows a great deal of promise. And the other option would be to fruit thin, and to fruit thin down to levels to correct problems with vine size we've seen some mixed results with that, and growers are not necessarily happy with the results. It's anecdotally attributed to vine damage and fruit damage associated with trying to take a very small crop down to an even smaller crop. So the only thing I want to touch on before I move to Jackie is just that, so these are the options that we have instead of shoot thinning. And the one thing that shoot thinning does offer us is really an inexpensive way to potentially dial in that large crop to something more manageable. We're still doing it early. This is right at the tail end of our frost season. So in doing so, we do assume some risk of frost, but we are certainly able to deal with some of the issues we've seen creeping up in terms of making sure we can do this variable rate, and we can do it with crop sizes that are completely prohibitive. So 15 to 20 tons per acre that we need to scale back to 10 tons per acre. This is really, I think, the only way we know how to do that effectively and reliably. The growers that have tried to do it through fruit thinning, it does create some issues just in terms of the practicality and costs associated with that.
All right, thank you, Kevin, for setting the stage for us and diving into some of the cost information. I'll try not to be redundant. I did work up a few things based on data that we collected in our study. But for my portion, we are going to briefly discuss what vineyard managers are looking to achieve with shoot thinning, which is traditionally done manually. We're going to spend most of the time talking about how to use variable rate technology to shoot thin mechanically. Then, as time allows, we will discuss how this all shakes out in terms of cost with our crop load model. All right. I'm not going to spend a lot of time on the rationale for shoot thinning as a cultural practice, but I suppose we do all have to know why we're here. So what are we after when we start plucking shoots off a spur or a cordon? From our perspective here in the juice grape belt, shoot thinning is primarily a means of crop load management in the constant pursuit of balancing a vine's yield with its ability to ripen it. That said, depending on timing, there are some fringe benefits you may enjoy by removing shoots, and some think of it more as a canopy management tool. I'd be happy to read some debate in the chat if you all want to start a dialogue on what you're looking for out of your shoot thinning efforts. But for the purposes of this presentation, once vines are pruned and shoots emerge from the buds that were retained, shoot thinning is our next opportunity to manage crop load. And as Kevin mentioned, we get a chance to take an exorbitantly large crop down a little bit and maybe potentially follow up with fruit thinning later in the season. So we're getting rid of shoots primarily to rid ourselves of the infantile clusters that would otherwise develop into a crop. Okay, so before you go off thinking it's all that simple, here's a look at a digitized version of some notes that Nelson Chalice once took on a napkin, captioned life goals. Dissecting this figure is a webinar series all on its own, but suffice it to say that crop load and its relationship to production and quality, whichever parameters you judge it on, is complex and dependent on the synergistic interactions of many factors. So this serves as a bit of a disclaimer. Whether or not a given practice in your vineyard, including shoot thinning, achieves its intended goal may depend widely on how the other contributing factors are managed. All right, so you're getting your crew together to go thin some shoots by hand. So Gerald White worked up some cost data associated with this practice, depending on the efficiency of your crew and your vineyard layout. So feel free to look at this in the PDF slides later if you want a closer look, or to see it in context in the references below. But best case scenario, you're spending about $38 per acre with a lightning fast crew and wide row and vine spacing. And worst case scenario, you're spending just over $200 per acre with tight vineyard spacing and an inefficient crew. So keep this cost range in your mind. and I'll try not to step on Kevin's toes here, but I did work up some of the costs associated with what we did on a research level, so we kept track of our time. And I used $15 an hour as my base rate just because that's what the White study used, so I wanted to keep it consistent. So some costs will scale with acreage and some are fixed, like Kevin mentioned in his portion. But all in all, it boils down to about $30 per acre in operation cost each time you variable rate shoot thin a 10-acre vineyard. Due to the fixed costs, the per acre cost gets down pretty quickly as you increase the area covered. So these numbers came from our experimental trials, I'll say again, over the past 3 growing seasons, and they take a few things for granted. The first is that you have access to someone who can work with your spatial data. And while our last webinar dealing with spatial data processing was a bit of a snooze fest, it should have at least given you the inkling that there's a right way and a wrong way to collect and work with spatial data. And while there are a lot of people out there who know enough to put a metric socket on a metric bolt, handling spatial vineyard data is a more mysterious component of the precision viticulture machine. As such, it requires some skilled labor. Lucky for you, there are some freeware options on the horizon, one of which is being developed as part of the Efficient Vineyard project that will do some of the basics automatically. Okay, so the first given is that you have access to appropriate data processing and mapping. The next given is that you have the equipment it requires to variable rate shoot thin. So consider these costs the ongoing costs once you're set up. Also, your personnel may make different rates, but like I said, I just used 15 as a base. So I know the burning question, but what about the gear? So here's what you need to get the job done, assuming you already have a vineyard tractor that will handle a PWM valve. PWM valve, what in tarnation is a PWM valve? Well, you can think of it a lot like a valve in the human circulatory system, the kind that regulate blood flow in our bodies. Only here we're talking about the circulatory system of ag equipment, which runs on hydraulic fluid. The PWM valve, number 3 in the figure, takes digital instructions from the brain of the system, the field computer, shown in number 4, and regulates the hydraulic flow to the motor powering the thinning heads, shown in number 2. So the digital instructions are tied to a position in space, which we discern with the help of our GPS antenna. Remember in webinar 1 when I told you that would be important? So how do we know what to do where? Well, figuring out what to do, where, and how to do it is what we'll be talking about for the rest of this webinar. And it all starts with a spectral reflectance sensor shown in number 1. All in all, this system cost us $48K when we put it together for our research trials. A scary figure, yes, but it is assumed, as Kevin mentioned, that shoot thinning will be one of many practices that will utilize this system, so the cost would be spread out if you adopt a system of vineyard mechanization a lot like Justin Morris pioneered. So now that you're all fully sticker shocked, let's get into the fun part, the protocol. Well, before we can decide how many shoots we want to remove and where, we need to know how many we have and where. So in comes proximal sensing. These sensors measure the unique spectral signature of vegetation. And if we get out early enough, 2 to 4 inch shoots, we can get a relative map of shoot count across a 40-acre block before lunch. And we're going to need that efficiency because our window of opportunity is short, as Kevin mentioned. For the mechanical shoot thinning heads to do a good job, we really need to have this job sewn up by 6-inch shoots, or we just succeed in breaking the shoots and leaving the clusters viable. Ask me how I know. Since I don't have any footage of scanning at the appropriate stage, I threw in some photos so you get the idea. From our experience, once the leaves start overlapping, the relationship between shoot number and NDVI goes right out the window, and you're going to be stuck counting more shoots manually. And who wants to do that? I should also mention that you could probably use a UAV to capture this data as well. I just cannot personally speak to any published research nor personal experience linking shoot number to UAV-based NDVI. Feel free to clue me in if you have any information on this. Always love to learn. Okay, so we have our NDVI, and our spatial data wizards have turned the raw data into a pretty picture for us. So we can now appreciate that there are areas of the vineyard with more shoots and fewer shoots. Why could this have happened? Feel free to throw some ideas out in the chat. Maybe you had a pruning crew who really liked to work fast and not pay too much attention to internode length. Maybe you machine pruned and didn't get a chance to hand follow up. Maybe there was a nasty spring frost. Could also be that you did not have a very synchronous bud break and there are still some shoots that are going to emerge after this scan. We hope not, but it happens. Nonetheless, this map is showing you in blue where there are more shoots and in red where there are less shoots. So if you prune this vineyard yourself, this might be enough for you to make a decision based on your intrinsic knowledge of how many shoots may be out there in the various areas and how many you'd like to be out there. But perhaps we might like a legend that indicated how many shoots per vine we're talking about. And for this, we're going to need to lace up our boots, grab our clicker, and go count. But first, we must know where to go. So we break the vineyard up into our proposed management classes. For more on this, check out our last webinar, coffee recommended. And we delineate some samples in each of those areas, taking care to avoid transition areas or edges wherever possible. Okay, so we grab our clipboard and head out. Got our little shoot thinning crew here, and don't let the video scare you. This does not actually require an army. Shoot counts in hand, we look at how our NDVI samples relate to our shoot counts. In this case, you can see the mean separation between the management classes reflected in the plot, and a nice relationship between NDVI and shoot count, or at least the best you could hope for with limited samples in a highly variable vineyard. So we can use this relationship to translate our NDVI map into a predicted shoot count map. I did have a reference in there, albeit with some error encompassed in the result. So a commercial version of the CMU imaging unit you learned about in webinar 5 would likely provide a more accurate high-res shoot count map, but until that day comes, we're really happy with the results that NDVI and a little legwork can give you. Oh, there's my reference down there. So the reference deals with translating NDVI to a pruning weight map, which takes place at a different phenological period in the season, but a nice read there. So armed with our spatial map of shoot number, we must now deliberate. What level of shoot removal do we want to achieve? This decision, without the accompaniment of prior season's spatial yield and vine size data, is heavily reliant on the vineyard manager's knowledge of vine capacity and how it presents itself in space. So for the purposes of our trial, we let the commercial growers take the lead and did our best to guide the machinery toward achieving their management goal. So once the grower decided on the thinning level, we got busy making a prescription map so the cockpit didn't have to look so empty. Decision made, coded into prescription map, and we're off and running, right? Well, not so fast. So we know we want to remove 30% of shoots in management class 1, 45% in 2, and 25% in 3. But do we know how to achieve that with our machine? The only way to find out is to calibrate. So the prescription map in our field computer sends instructions to our PWM valve, which controls hydraulic flow to the motors turning our shoot thinning heads, depending on our position. But we need to know what flow rate corresponds to what RPM, so we can make our heads turn faster or slower, depending on our desired thinning rate. So our first test began in a parking lot, and once we had a few rates we liked, our crew put a tachometer on the thinning heads to give us the exact RPM values that corresponded to our desired flow rates coming from the field computer. So we are ready to head to the vineyard. We upload our vineyard-specific calibration map into the field computer and have a chat about what rates to test incrementally in a vineyard row. We always make a few tweaks depending on the growth stage. We count shoots before any calibration thinning and then let Andy loose on the calibration row. So this is exactly the same as what we set up in the parking lot, with rates changing incrementally. So you can see the little orange tags hanging there in the trellis. So those correspond to the different color areas on the map, each with a slightly different rate. So then when we are done thinning, we count shoots after and calculate what RPM we need in that vineyard to give us the desired thinning rate in each management class. This process should streamline quite a bit in commercial settings, but for research purposes, we really wanted to make sure we were running a tight ship with our removal rates. So now comes the fun part. If I can get this to play. Once the rates are set up in the full field prescription map, the operator just has to drive, and the thinning heads make the adjustment in rate all by themselves to achieve the desired level of shoot thinning. So you can rest assured that the spatial data-driven decision-making has already taken place by the vineyard manager, and the vineyard machine is following its orders. So we have thinned our vineyard. Usually takes one operator. Oh, like our cheerful Andy shown here, about half a day to finish 20 acres, really conservative estimate there. And since I know you're thinking it, I will mention there's a trade-off for this speed, and that is the inability of the machine to select the weaker or poorly placed shoots to remove. It's really a probability game of which shoots the paddles are going to make contact with. So in this pan, you can see a few shoots along this cane have been removed, but once we get to the top, 2 are right next to each other. So we've only tested this in high wire cordon, but I presume there'd be some variance depending on the trellis system and how it's trained. All right, so after shoot thinning, we head back out to do our post thinning counts to verify if we achieved our desired rates of thinning in each management class. And throughout the season, we're measuring yield components and fruit composition to compare our thinned areas to the unthinned control. At the end of the season, if we have a yield monitor, we can get a bird's eye view of the yield response to our thinning. So we'll continue to look at this field as a case study, but we did replicate this work in a total of 5 sites over 2 seasons. So as we discussed earlier, we're primarily interested in crop load, expressed as Rivaz index here, which is yield divided by pruning weight per vine or per foot of row. In management class 2, we were looking to remove 30% of our shoots. From our before and after sample counts, the thinned areas had 31% fewer shoots. Hooray! 26% lower yield, 17% higher pruning weight, adding up to a reduction from 48 to 25 in Rivaz index and 16% higher juice-soluble solids, almost 3 full bricks at harvest. And for juice grape growers, you get paid on bricks on a scale, and then it's dependent on how much yield. So you want to maximize your yield and maximize your bricks. So this added up to a $250 higher revenue per acre when compared with the unthinned control. This may not seem a lot to those of you in premium wine regions, but out here that means a lot to a grower. So in management class 2, we wanted to remove 45% of shoots, and we only hit 23, so we missed the mark a bit on this one. Nonetheless, compared with the Rivaz index of 48 in the control, our thinned vines were closer to balanced at 30. Again, thinned vines carried riper fruit, though only 1.6 higher bricks at harvest. Running this through the payment scale, we grossed an extra $442 per acre in this management class. And then in management class 3, we wanted to reduce shoot number by 25%. We overshot a bit here at 29%, but did not see a corresponding decrease in yield. We did observe some secondary clusters in this section just post-veraison, so it's possible that this played a role in the reduced bricks at harvest and lack of yield reduction. That wasn't really scientific, that was just sort of an anecdotal observation, but due to the larger vines in the thinned area though, the Rivaz index came in at 32 versus 40 in the control. So we actually lost money in this management class, but the increase in pruning weight means that these vines are going to be able to handle a larger crop next year. And we got some time here. So to give you an idea of the payoff period for this practice, let's consider a hypothetical vineyard. So imagine this vineyard's area, and I know it's not exactly a third, but it's split equally into 3 management classes with 1 pound, 1.5 pound, and 2 pound vines, respectively. So using the crop load model developed for Concord by Dr. Terry Bates, I ran 2 hypothetical scenarios. The first lets the vineyard do its thing. We prune to our desired known number, and we don't adjust crop from there. So in year 1 of this hypothetical study, 1 pound vines had 6 tons per acre, 1.5 pound vines carried 10 tons per acre, and 2 pound vines carried 12 tons per acre. So from there, the model takes over and gives us an estimate of bricks, return yield, and return pruning weight based on our crop load. So this is our gross revenue over 10 years in that vineyard. Between years 4 and 5, those 1 pound vines are producing next to nothing because they've been driven into the ground due to overcropping. By year 9, they might be starting to rebuild themselves and produce some crop, but now the 1.5 pound vines are less than half a pound. So they're not producing very much either. The 2 pound vines performed pretty well, and I'm going to go back just to point out on this figure here, you can kind of see that there's a sill here. So once you get, this shows it about 2.5 pound vines, but once you get up into this area, those vines are just a little bit more resilient when it comes to regulating their own crop load and not needing a whole lot of help. But we would argue that most of the vines in our belt are not quite there. So the second scenario here in blue requires balancing crop load by reducing yield, and that could be through shoot thinning or a combination of shoot thinning and fruit thinning, or just fruit thinning. So when the crop estimate comes in higher than the vines can handle, we're taking that yield down to balance crop load based on our crop load model. So the first year, we lose money due to the reduction in yield, but in just the second year, balancing the crop starts to gross higher levels as vine size is preserved and fruit quality, measured in juice-soluble solids for juice grapes, goes up. So the yellow line is the difference between these two management practices. So in this case, it would be the gross revenue from balancing crop load minus the gross revenue from the unadjusted vineyard. So let's say we achieve this balance solely through shoot thinning. If we subtract our operating cost each year by area, how long would it take to pay off our $48K in equipment if we were only using it for shoot thinning and nothing else? Again, not very realistic, but let's assume. Love worst case scenarios. So this table shows the payoff for this theoretical vineyard if it were 10, 20, 30, 40, or 50 acres. Worst case scenario, this would be a 7-year payoff based on our increased revenue from balancing crop load over time. But we get down to just 4 to 5 years at 40 acres. So this does scale up pretty quickly. So that was just a theoretical data set. This data set actually comes from the belt-wide average yield in our production region for Concord. So the red line is showing you the seesaw effect. And if we think back to our Nelson Shawless slide, this could be the interaction of many complex environmental and management factors. But really where we want to be is in the green. So if we're doing a good job of balancing our crop load, holding all other things constant, meaning you're doing a nice job managing your vineyard all around, water and nutrient balance and those type of things, then we really want to be looking at a scenario where we're slowly building our vine size, slowly building our ability to handle a larger crop over time. And you're still going to get those ebbs and flows season to season based on what Mother Nature gives you. But at the end of the day, we're going to end up more profitable over a long period of time by keeping it consistent. And who doesn't like a steady paycheck, right? Okay, and this took a small army, as you saw in the videos, to achieve. So I really wanted to take some time to thank our Clairol team, Rhiann Ekstrom, my right-hand lady and data processing wizard, Dan Sprague Jr. and Andy Joy fabricated anything we needed when we needed it, and were the brains behind the brawn, I guess you would say, of the mechanisms themselves. Terry Bates for leading the charge, Madonna, Paula, Scott, and Golnaz for getting out there and counting shoots and all kinds of weather, hot, cold, windy, didn't matter. They were always out there with a smile. And Kim Knappenberger and Damian Dodd for capturing so much excellent footage that I was able to mine from to make the videos for today. And we did do this research in commercial vineyards, so really want to take a minute to thank Beckman Farms, Sprague Farms, and Joy Farms for letting us thin some fruit off and being our guinea pigs. And I'll just leave this up, and at this point, happy to entertain any questions for me or also for Kevin for any portion of the webinar today. And we really appreciate your time with us.
Hey, Jackie.
Hi, Terry.
It's Terry. So for everyone who doesn't know, I mean, Jackie and I are in the same building. We're actually not in the same room. So if anybody has questions out there, please put them in the chat box, and we can talk about answering them. But for now, I wanted to talk to Jackie a little bit, ask her a couple of questions. So Jackie, can you give me a kind of a description of, so you've described variable rate shoot thinning, and kind of like, where does that fit in the whole overall vineyard mechanization approach?
I have to repeat the question for Kevin because we're sharing a set of headphones here. So you were asking, where does variable rate shoot thinning fit into an overall mechanical?
Yeah, so we've talked about Justin Morris, and 25 years ago, Justin Morris was here in our region, and of course other regions, California, and in the Midwest. He was an Arkansas boy. You know, and he talked about the systems approach to vineyard mechanization. So So you're just looking at kind of like one little sliver of the whole thing. So can you just kind of give us context of like, why would you shoot thin, and where does all this fit really?
Sure. The thing about shoot thinning is that it fills a gap, I think, in the mechanized process, or I shouldn't say fills a gap, but there's an issue with mechanization in that we need a pretty extensive amount of hand follow-up that costs somewhere between, and this is going to sound silly, but somewhere between $80 and $180 per acre. And that $80 is really just not sustainable over the long run. And I think maybe in the 70s and 80s, that was not necessarily realized, because it does work for up to a decade. And then there's some pretty intensive hand follow-up that happens that basically looks a lot like hand pruning. And as an industry, if we mechanize this whole region, I'm not sure where that labor is going to come from. And even if we don't mechanize, I don't know if that labor is going to be reliable going forward anyway. So this helps to fill some of that gap by reducing the density of the canopy in a really affordable way. And at the same time, it also helps control crop size and your balance in an affordable way as well. And we sort of touched on how fruit thinning is a relatively expensive practice compared to shoot thinning. So even though it's not widely adopted, it seems to make a lot of economic sense to move in that direction.
And I always think of this figure that Justin Morris shows of, one theoretical entire growing season. And I think he had something like 27 or 30 different machines that were all tailored to a very specific practice in the vineyard. And he would show this, sort of a thematic way to manage a vineyard by employing those machines at various times and the practices that would accompany them. So the way we've sort of adapted it in the juice grape belt, and this is by no means just tailored to what we do here. This can scale to any region. And, as with anything, your vineyard best. So feel free to take the things that work for you and leave the rest. But for us, the first way we're going to set crop is through pruning. Because of our labor shortages, because of the economic pressure here, as Kevin mentioned, we tend to have a mechanized pruning with some hand follow-up that might have to be really speedy. So these are not, as you saw from the videos, highly manicured vineyards by any sense of the word. But pruning is still our first chance to set the crop. And we experience quite a bit of spring frost here. So by leaving a little bit extra, a few extra nodes than you really need, that sort of becomes a little bit of a frost insurance for people. But then if you don't come back and adjust that somehow, you're going to run into that, as you saw in that slide, where you're having this seesaw effect of overcropping in incremental years. So by shoot thinning, you're able to reduce that shoot number to something manageable. And then mid-season, and this will be a webinar where we talk about how we estimate crop here. So we come in at 30 days after bloom, which we know is about 50% of final berry weight here. And so the crop is about half of its final size. So we'll come out and we'll do our crop estimation at 30 days and give ourselves a spatial crop estimate. And then we can come in, if the harvester is set up to do it, and variable rate fruit thin so that we're balancing crop across a vineyard. And then we can chase that up with evaluating our yield through the use of yield monitors. And we have some other prototype technology that might evaluate some juice fruit composition components. And then we can kind of evaluate, how do we do? And the reference that I showed, which is a James Taylor paper on translating NDVI to pruning weight, by taking NDVI throughout the season, we're able to give ourselves some sample locations to go take pruning weights, and then we can give ourselves a pruning weight map. So we have our vigor maps throughout the season with NDVI. We impose some management that's data-driven. We come back with our yield monitor. We see how we did. We get a pruning weight map. Those two can be combined into a crop load map, and that's going to be a webinar all on its own as well. And then we can have that data to help inform our management decisions the next year, which we can implement through variable rate management mechanically, or you can use it to implement decisions manually. It's we're sort of agnostic in that department, but this is how we do it because we have to.
So, okay. So a point, I think you're kind of getting around to in a very simplistic fashion, because I think the shoot thinning is just an example of one example of potential variable rate management. So going back to the Justin Morris vineyard mechanization system is, you know, in a perfect world, I see every vine myself. I prune every vine myself. I may adjust bud number based on that vine capacity. If I leave some uniform bud count, I may go back and do variable rate shoot thinning by hand. And as we get to the point where labor quantity and quality continues to go down and the cost of it continues to go up, right? We're moving more towards these mechanized systems. And I think the major point is that we're applying a uniform application to a non-uniform system. So like if you look at all the work that Justin Morris did, it was all uniform application in a non-uniform system. So we are taking the base of that system. So mechanical pruning, mechanical shoot thinning, mechanical fruit thinning. And now we're trying to add a level of variable rate, you know. So whether you're a VSP wine grape grower and you want 4 shoots per foot a row, and by mechanical pre-pruning, you're not getting that. Right? You're not getting that uniformity across the vineyard. I think what you're showing is that this NDVI map early in the season validated against some, you know, a lower density amount of shoot counts. You can come up with a shoot density map, which you can program into the machine and say, I want 4 to 5 shoots per foot a row going across that vineyard. Set your machine to do it. That's kind of like, to me, the easiest case scenario. What we do with Concord's a little bit more complicated, because now we're going in and saying, you know, do we have a spatial map of vine capacity, and can we match shoot number with that vine capacity using a machine? So I don't know if there's a question in there other than, you know, shoot thinning is one part of the whole mechanization system, and it's a really good example to what you could possibly do with other applications. So I guess maybe the question is, what other vineyard applications do you see this kind of variable rate management, you know, the system of collect spatial data, use that spatial data to drive your management decisions, and then you're gonna apply it somehow. Can you touch on maybe some of the other applications that might be out there?
Sure. I think I would always start with just measuring first. Just get a really good handle for a couple seasons, you know, maybe invest in some sensors like a yield monitor and NDVI, whether it's UAV or ground-based, and just get an idea of how your spatial patterns manifest. And then I would highly recommend taking a look at your soil, whether that's through EC surveying or gamma sensing or any of the other options that we touched on in, I think it was webinar 2 and 3. And just kind of get a sense of where you're at and how temporally stable, meaning how stable across seasons these patterns are. And then the next step would be management. So shoot thinning is one of those things. Variable rate fruit thinning is one of those things. Variable rate nutrition, fertilizer. Maybe you want to target a tiling effort if you have problems with vineyard drainage, but you don't have the money to do the entire vineyard. NDVI can really alert you to, hey, I got a problem here, and you can just focus your efforts there. So this is just one small component of a more holistic approach to just understanding the spatial patterns in your vineyard, which, you know, back in the day when you're managing 10 acres yourself and you're touching every vine every season, you knew that. But now as farmers are getting bigger, as there's more people involved in managing a vineyard, this is just a tool to keep a handle on those things. And not only that, but to have something that will transfer with the ownership of your vineyard. So you're not just selling a plot of land, you're selling your vineyard plus the entire archive of all the spatial data and management decisions that you've made, including, you know, how much spray material you put on where every single season. I mean, just even making spray records easier to handle is, there's so many things, definitely. We do have a couple questions, one in the Q&A box about, go ahead.
If I could just address what Terry said really quickly. I think shoot thinning is a good example in the sense that it's the low hanging fruit. So we're looking for an inexpensive way to variable rate adjust crop load. And I think that's the most important economic impact we can have with variable rate technology. So then I think that logically leads us to say that fruit thinning variable rate is probably tied with or the next most important piece of technology that a grower could adopt. And then from there, like Jackie said, there's tons and tons of pieces of equipment that growers could use that could be implemented in a variable rate way. The return on investment would probably not be as dramatic or as fast. Just to highlight what I mean by that is growers typically do things a little bit differently than we do in a research plot or here at Clairol. They probably average fruit thinning once every 10 years. And the last time we had some major fruit thinning done, we looked at 20 different farmers' blocks, and their return crop was around 0.6. So every ton they took off, the following year they gained 0.6 tons. With variable rate technology, we had a grower that was able to take off 1 ton and gain 2 ton the following year. So we see some room for improvement just by variable rate managing something that's actually variable rather than trying to apply uniform management to such a critical part of the production.
Awesome. Thank you, Kevin. Let's see, a couple questions here. The first, do the mechanical shoot thinners damage the cordon or spurs? If so, do you also need to address the potential of grapevine trunk disease? Great question. We have not experienced any damage notably from the thinning heads. As you can see, the paddles themselves are pretty flexible. So, I mean, they could bat your hand, and I wouldn't recommend it, but you're probably not going to need a trip to the doctors or anything like that. They're pretty flexible. So they tend to just sort of bounce off posts or things like that. But that being said, anytime you're getting into mechanization, you're increasing the incidence for injury from a machine, whether that's a tractor tire or whether that's an implement. And one thing, keep an eye out on the horizon. I think in California, it's fairly common for the trunk to be trained to a post on its own. We're experimenting with that a little bit on the East Coast out here, but I think if you have a training system where you have a nice straight trunk, you're going to reduce the incidence for something like that. Cordon for us was a non-issue. If anyone has any experience with that, feel free to pop in, but that definitely wasn't an issue for us. Another one, if you get shoot density right via variable rate thinning, does this reduce the necessity for mechanical cluster thinning? For example, does shoot thinning do 80% of the work or 30% of the work? Shoot thinning, the real advantage to shoot thinning, as Kevin mentioned, is when you have a crop that's almost too big to handle just with fruit thinning. And in speaking with a lot of growers, running your harvester to mechanically fruit thin it's tough on the machine. You're putting hours on it. You're going to increase your incidence of having to do a large overhaul on it in terms of mechanically maintaining it. So if we can just get a tractor out there with a tool carrier that can also hold a pruner or other implements, it's going to be a lot easier on your harvester, which is probably your most important asset on your farm. So just alone, that is a huge benefit to shoot thinning versus cluster thinning. Cluster thinning, I think, is really nice because you kind of already know what you're dealing with, both in the environmental conditions of that season and also with the amount of yield you're expecting to harvest if you've done a crop estimate. So you have a little bit more of an informed decision about the yield that you're targeting and how your thinning is going to address that.
Yeah, the only other thing I would add is I think from the perspective of the mechanics and technology, you can do 90% of the work with shoot thinning, but do you want to? So like Jackie said, you probably don't want to. You want to allow yourself to postpone some of that decision making to later in the year when you know more about berry size. But it's certainly the most affordable way to accomplish it. And we know of some instances where you can't do 100% of the work with fruit thinning. So that's where this tool comes into play.
Yeah. And I think one of the drawbacks in thinning shoots that we notice is just that sometimes you have secondaries that push. And I guess that just sort of comes with the territory when you're doing it as early as we are. So, you know, maybe you send a crew in just post veraison, you say, all right, grab anything green and drop it. You know, people do that anyway in a lot of premium wine vineyards. So that just might be something that needs to supplement. And this is our first crack at it on a research level, doing this sort of variable rate management with shoot thinning. So as we continue to research and as people start to adopt this, we're going to figure out all of those things just through trial and error. And last question I'm seeing is what future input sensors, in addition to NDVI, do you foresee? Yeah, spectral reflectance is one that is inexpensive, really easy to run, and the information correlates well to things like exposed leaf area or pruning weight or early season shoot counts, depending on the timing. So we like it, and as Kevin mentioned, the fact that it tailors well to other vineyard operations is an added bonus. There's a whole webinar on different soil sensors that are in the market or coming to market, so you can check that out. The CMU imaging unit, when that is commercialized, I think that will be an investment, but I think it'll be one that gives you an absolute map. The drawback of NDVI or any spectral index map is that it's relative. So you have to do some calibration in order to translate it. And the imaging sensor, I think will still require a little bit of boots on the ground, but probably not as much. Not as intensive as the spectral reflectance. And I mean, there's all kind of sensors in the market. There's LiDAR, there's different ultrasonic sensors, there's different thermal sensors. And, you know, part of this project is keeping abreast of those things. And in the early stages of Efficient Vineyard, there was a lot of work focused on LiDAR. So maybe it's time to give that another shot. We'll see. But yeah, there's a lot of things that were available, but we had to really focus on what we were going to try to develop. So NDVI was a great way to develop protocols that people can adopt and implement now. And if there's another sensor that comes to market that can do a better job, just swap it out. The protocol is already in place and you're already comfortable running the equipment. So that's an advantage. And then there's a couple other sensors that we're developing as part of this project, namely to complement a yield monitor and give you some indication of your juice quality. For us, as I've mentioned incessantly, is bricks, but also, you know, color or pH or something like that might be really interesting to winemakers. So being able to go to your winery and hand the winemaker a spatial map of the juice pH from that block, I mean, I see a tremendous amount of value in that. So a lot of our effort, I think, will be focused on that avenue, but it's a great wide world of precision viticulture out there. So we're just bringing you a little slice of the pizza. Anything else on your end, Terry?
I could have a 20-minute discussion with Tim Martinson on that. His question, it's a really good question. The short answer is that we have, again, from a non-variable rate standpoint, we've answered a lot of those questions through research trials here at the lab. You know, with Concord, we had a big mechanization trial where we compared 3 different levels of hand pruning, and then treatments that had, you know, a light pruning or high node number at 2 different shoot thinning rates, and then fruit thinning by hand or by machine. And we compared all those treatments. I mean, really, the short answer to his question is yes. If you do a mechanical pruning with hand follow-up, and then that reduces your need to do shoot thinning or fruit thinning. So it's really nice because now you're at the point where you're fine tuning, you know, what's my shoot thinning rate, what's my fruit thinning rate, and I can, you know, I've gotten 80% of the way there with my machine pruning and hand follow-up, and now I get the rest of the 20%, and now we're trying to make that variable rate. So do I want to do the rest of the 5%, or do I want to do the rest of the 20%? On different parts of the vineyard. So I'll just leave it there.
Okay, I'm sure you're all seeing Tim's feedback on there. Yeah, I mean, the nice thing is as I mentioned, this is just one protocol for one practice. that you can take or leave or tweak or whatever that suits your management goals in your vineyard. So these are just the tools, and you can use them however works for you. So anybody else have anything for the good of the order? Okay, cool. Well, I guess we'll wrap it there, everyone. We just really appreciate your time with us today, and feel free to check out the recorded version if you want to go back and hear anything again. And Bob, why don't you just variable rate machine prune? Yeah, we'll work on that too.
No, I don't want a variable rate machine prune. I want to leave in our system. So again, it's going to be different depending on what you're growing and where you're growing it. But the system that we've kind of adopted, again, going back to Justin Morris's, I'm going to prune to a very high node number because I want to set maximum crop potential. And then if I have cold damage or spring frost, well, that'll get knocked down. If I don't have cold damage, well, then I have all these shoots that come out, fruiting shoots that come out. And I can knock some of those off with the shoot thinning. Do I want to knock off all of them to set my crop, where I want it? Well, we kind of still have this spring frost thing going on. So, I start with high crop potential, I dial it down with the shoot thinning, I get past spring frost problems, and then at 30 days after bloom, I can see where my season is going. Am I having a great warm growing season where I can hang more crop, or do I need to take off a little more to get good crop balance? I agree with Tim Martinson. It would be, well, I would really love to set my node number in the winter and walk away from it and never have to worry about it again, but that's not the reality of our situation. I would like to get my shoot density right, but if I'm still kind of on the fence with any kind of frost damage, then I kind of want to leave a little extra to make sure I have crop there, and then I can really dial things in at 30 days after bloom. So again, really what we're describing is that systems approach to vineyard mechanization that Justin talked about 25 years ago, and we're still working on it.
Yeah, I think variable rate machine pruning is also a little bit more difficult of a thing to solve mechanically, just because there are so many different setups of machines, and it's, controlling hydraulic flow to a motor that's spinning a mechanism is pretty simple. But when you have, maybe 4 different rotary cutters and all sorts of different mechanisms, moving those to achieve that variable rate pruning, not going to say it can't be done. I just think it's a more difficult thing to solve than shoot thinning. Is there any difference in upright spurs versus downward spurs in how mechanical shoot thinning is set up? So you can set up the motors to spin either way, up or down. And the nice thing about that tool carrier is you can actually move it in the canopy. And we do have vineyards where our operator actually positions the shoot thinning heads further down, so that tool carrier goes over top of the high cordon wire. And so I think it's pretty adaptable to different trellising systems. We just haven't personally tested it in other ones, but we will be out in California in a few months doing a demo, so stay tuned for that. And that will be with the Midwest Grower Supply trailer version that has the double row trailer. Okay, perfect.
If we can get it working.
We'll do it. Okay, great. Well, thank you, everyone. As usual, feel free to fire questions at us that may come up in the meantime, and we'll see you next month.
Thank you.